Hey everyone, thanks for stopping by my talk Bitor at BlackHat 2025. I'm going to be talking about the tool that I built, kind of what it can do, and yeah, I'm excited for you guys to check it out. With that in mind, so here is the agenda. First, I'm going to do a quick little introduction about who I am, where I came from. We're going to talk a little bit about what ASM is, Attack Surface Management. We're also going to talk about nuclei and why I chose that as the primary scanning platform for Bitor. We're going to talk about the problem I was facing, and then we're going to talk about Bitor and do a little demo. I'll show you how it works, and then we'll wrap it up with some conclusions. So who am I? My name is Ralph May. You can see by all the links in here. I got a GitHub, got a LinkedIn. I teach a class called HackerOps. I also have two companies, Mayweather Group, where I do consulting for security. I also have another company called B10 Labs, where I create really cool tools for other consultancies to help do their job, kind of like what Bitor is. So essentially, I'm a founder. My background, I spent about 10 years in pen testing and security consulting. Before that, I have a military background. I worked at USASOC over here in Tampa, and yeah. What is ASM? So ASM is Attack Surface Management. If you haven't heard of it, then I'm surprised because every vendor out there is kind of shilling out a product that's going to help you do attack surface management. But let me break it down for you just a little bit about what it is and kind of how it works. So attack surface management is really a concept of trying to do continuous discovery, okay? And what we're looking for primarily is to find all of our internet exposed devices. And we're also looking to enumerate those for any kind of findings that might be out there. Now, we've had vulnerability scanners for a long time. So what is attack surface management and how is that different? Well, the idea is that a lot of those vulnerability scanners were just doing it once a year. Whereas attack surface management, we're going to run these scans maybe once a week, once a month. The idea is that we want to get a lot of data about our attack surface and how it changes so that we can respond faster. Additionally, another big concept that came with this concept of attack surface management is risk prioritization. So what we're trying to do is we're trying to figure out what our most vulnerable things are. Now, there's lots of ways to create that risk prioritization, but the one way that has been applied is to have professionals evaluate that information and then apply their own risk to it. Another way is using AI, which is kind of the up and coming way. But in general, with attack surface management, we're not just looking to create a high, medium, low. We're also looking to adjust those ratings based on the customer. Another feature of attack surface management is some integrations. So what if I'm vulnerable to this? How do I let everyone know? So for scanning every week, we need some kind of way to funnel that in to help someone fix it. So this would be moving into a ticketing system or a SOAR platform, or if you're the actual developer of this application, this would be using some kind of DevSecOps pipeline to let the developer know that there's a vulnerability with this system and that they should apply some remediation, right? Another thing attack surface management looks to accomplish is some more real-time monitoring. So if we're running scans every week and new vulnerabilities come out all the time, maybe we could get some kind of alert when this new vulnerability that just came out also just happens to affect our infrastructure. Additionally, you might set up your ASM product or whatever you're doing to actually run a scan when new very high level or certain level severities actually happen in your environment, right? So the ultimate goal is to lower that time to remediation and or time to detection, right? Another thing attack surface management provides is visibility and context, okay? So this should help get a full context of your external attack surface. Technically, you can apply ASM for internal as well, but for the majority of this talk, we're just going to be focused on the external. This can help provide business context and other things where you're just focusing on, what the most important things to your organization or to your external attack surface. All right, with that in mind, let's talk about nuclei. And if you take nothing at all from Bitor or this presentation, if you haven't used nuclei or gone and checked it out, you definitely should. It is totally worth the little detour to figure out what nuclei is and how it works. That said, I'm going to go ahead and give you a quick explainer. So what is it? So nuclei is a high-performance vulnerability scanner. And its goal is to be simple and to find vulnerabilities quickly and efficiently. It is Golang based and actually is very fast. It uses a simple YAML-based vulnerability template, which are really easy to write. You don't need to know Golang to write templates. And that has created a whole repository full of vulnerability templates that you can use with nuclei. Additionally, because it's so easy to make, there's a whole community repository that's growing every day when new vulnerabilities come out, and they're able to quickly add them into the repository. It also supports multiple protocols. When I first heard of nuclei, I only thought of it as a HTTP, so a web application scanner. That is not true. It is a full vulnerability scanner. So it does support things like direct TCP, DNS, SSL, Whois, JavaScript, among others. It's also really fast. It can do a lot of parallel scanning. It also does request clustering, which is kind of the idea of doing a bunch of scans on this in a cluster. It can also do a lot of parallel scans to get these vulnerability scanning done faster. This does create a little bit of a backpull if the environment can't handle that level of scanning, but it is able to do a lot of scans very quick. Nuclei just runs as a CLI. You can see this is just the output of that CLI, and it runs pretty simple. So you could say nuclei, give it a domain or an IP address, and it will run all the templates looking for any vulnerability that it can find. Now, you may say, well, I just gave it a web address. It's going to avoid doing some templates that don't apply, right? And by default, it does not do some DDoS and other things like that. But in general, it is very simple to use, and it is just a CLI tool. Additionally, here are the templates. They are just a YAML file, and they're pretty easy to read, letting you know what it's looking for and also showing you how the request would work and what kind of matchers it's looking. So in an HTTP request, it's pretty simple. I'm going to send out this request to an address with these possible payload, right? In this case, it's a post to the proper URI. And when that post comes back, if it does respond, I'm looking to match certain things in the response to identify if that vulnerability exists. Additionally, there's a little digest on the bottom, and this is to keep a hash of these so that we don't necessarily get malicious templates. So why did I choose nuclei to build essentially an open source ASM product? One, it gave us actionable results and high confidence, okay? At my last job, I helped build out their pen testing as a service or penetration platform that we were running scans on customers all the time. And we found that nuclei gave the very best results out of all the scanners that we could kind of get our hands on, right? Additionally, it was free and accessible to everybody. It was also really fast. We got our results back quickly. And the most important, it was easy to customize these YAML templates. So when we were doing this penetration testing as a service all the time, we wanted to be able to customize the scans to maybe just look for one thing across all of our customers. And nuclei allowed us to quickly do that without having to create a full big scan with a lot of these other commercial platforms. All right, so that's great, but we have a problem. how do we run these nuclei scans at scale? So the problem was presented in the sense of I need to scan a lot of customers all at once. So not just my environment, right? Some ASM products you could buy just to scan your company. But as a consultant, I've been tasked to scan a bunch of companies that are all subscribing to our service, right? And to do that, I need to be able to run my vulnerability scans at scale and at often. So one of the problems we found is obviously the need to scan lots of clients, okay? And because Nuclei was giving us good results, we also realized, though, that it was just a CLI and JSON, so we needed to build some automation. There's no way we can scan 10 or 100 clients a week in a manual process. That would essentially take away any of the value as we have to keep adding more consultants to run these scans, and we also increase our possibility of there being human error. Another thing we needed was highly customizable scans for these, and we needed to be customizable across a large swath of customers, not just an individual customer. Another issue that we found when running nuclei scans at scale is essentially companies would, on purpose, by some policy, block our scans because they receive too much traffic in a certain amount of time. So we needed to have a broad, scalable IP range that we could scan from to not necessarily bypass, but to avoid these kind of lockouts. My first attempt at trying to solve some of these problems was to build some kind of CI/CD pipeline to run these scans on a large group of customers. I decided to use Ansible and Terraform because those were both two software stacks that I understood and they could solve the deployment and the execution problem. And the way it works is I would trigger a scan via CI/CD. Another name for this has been called GitOps, but in essence, you store all of this code into a Git repository and you use some kind of runner to start it. And I would start the scan, and eventually the scan would go run some Terraform, deploy a virtual machine, and once the virtual machine was online, it would execute Ansible to actually run the scan, and it would save that output to an S3 bucket. This created definitely a highly scalable scan automation because every time I asked it to run a scan, it would create another VM for that customer. And so one customer per VM, I could scale up quickly. If I had 10 customers, I have 10 VMs scanning at once, all different IPs. You can see how this kind of scales vertically. Finally, in my first attempt at kind of doing nuclei scanning automation was I integrated this with Jira, which is the ticketing system I was using. And this would allow us to get tickets when the scan had completed. Additionally, in that ticket would be the location on the S3 bucket where the JSON file was. The JSON file is the output of the nuclei scan. And inside of that would have all the findings and what it did and what failed and so on and so forth. And this worked great, but obviously there were some issues that I wanted to solve. So one of the first issues was that while GitOps is great, it is kind of a code-only interface, so there's no GUI and no way to give others the ability to kind of get involved. Sure, if they learn what's in the code, they can absolutely, but now we have to do git commits and pulls and other stuff like that, so this can slow down the process for someone who's unfamiliar with what the code does. Another big issue is while we did have a history of what had scanned, we had no way to like do any correlation or look at a dashboard of those scans and what had actually happened. Now, to build that, in essence, I would need to bring something else because Git by itself doesn't really support that. The findings were saved, but I had no way to track any of that data, right? So I'd have to create something to track it. In essence, I just didn't have a database, okay? So while I had the data, I didn't have a way to kind of search through the data in an organized fashion, right? Especially across customers and across customer scans. So no searching functionality was really kind of an Achilles heel here. And the more data you get, the worse it becomes. It was definitely better than manual scans, but it lacked the visibility and metrics that you kind of need to scale this above and beyond a small subset of customers, right? So here was the next steps in kind of the evolution of Bitor. Let's build a web application, which we've all kind of come to accept as the best platform for working together. Almost all of the products that we use nowadays are SaaS platforms or web applications. So let's build a UI in a web that's simple to use and allows us to kind of see all of this data. One of the big things this allows is for team collaboration. If you're just running a nuclei scan or vulnerability scan for yourself and you're always going to be by yourself, then a UI is kind of extra. But as soon as you add more people, it becomes almost a necessity for scaling this out, or more customers, right? And this allowed us to support large-scale scans with no coding. People who were actually looking at the vulnerability data didn't necessarily need to understand the code that I wrote in the Git repository to make changes or to adapt and evolve. Another big feature is that this allowed me to visualize that data and allow you to search through that data with now a database. And you could search without learning how to search manually through this. You had a web interface that you could see how the search was responding and see that data. So what about Project Discovery Cloud? Now, if you haven't heard of Nuclei, you might not have heard of Project Discovery Cloud, but Project Discovery Cloud is Nuclei's, in essence, SaaS product for doing external ASM. And we checked this out before I built Bitor, but some of the issues were high cost. As a consultancy, we would have to pass that cost off to the customer. Some customers may have a couple hundred assets, whereas others could have thousands across, and they could adapt and evolve. While those customers may be able to afford, it makes it harder for us to predict the pricing, and we have to pass that off. And if it's high pricing, then it becomes a lot harder to be profitable. It was also black box. So while the results and the input I understood, how it worked in the background, or if there was a failure, I have no idea. Additionally, while there was a large scope of IP addresses it could have come from, I didn't have the way to control just a single IP. And what we found is that some customers wanted us to be able to kind of dial it in and say, I just want you to come from one IP, as opposed to trying to play the cat and mouse game of avoiding our detections or blocks. Another issue is the customer data exposure. Now, depending on how you feel about this, there's lots of pros and cons, but in general, we wanted to have that little bit more data custodialship for customer data, and building a platform that we knew where the data was made us feel more comfortable. And finally, we tested it out, and it did work, but sometimes it would fail, and we had no idea why, okay? And when you're selling this service as a professional service where you understand what's going on, it becomes difficult to explain that, well, this other product that we used just didn't work and we're not sure why. Of course, you could put in a ticket and they would go figure that out, but we're the experts here. And at the end of the day, we're trying to find vulnerabilities and execute pen tests quickly. With that all in mind, that's why I built Bitor. So what is Bitor? So Bitor, in a simple term, is a way to run nuclei scans at scale. You saw I tried with CI/CD, and then I realized that if I wanted my team to work on this, I needed some kind of interface. And that's what I built. Some design decisions I made in the very beginning was to make this self-hosted and no internet required. And what I mean by that is you don't need to publicly expose this to run the scans, because what it does is it uses cloud assets to actually run the scans and then sends the data back. You don't need to open up any ports. You do need the internet, but you don't need to be publicly exposed on the internet to run Bitor. It's multi-user, it's multi-cloud, it supports multiple different clouds because of the Terraform backing, and it's a simple to use web interface, so you don't need to necessarily learn another CLI. I love my CLI tools, and they definitely have a purpose and a place. But as a team, it's very difficult to work in a team function of a CLI. And some people may just not know that tool, and the onboarding time is just too long. Here's a simple diagram of kind of how these scans work. Not getting into all the deep technical details, but Bitor is tasked with running a nuclei scan. What it will do is it will use Terraform to automatically create the Terraform code, and it will deploy that VM to one of your cloud providers. Additionally, it'll also create Ansible code that gets shipped off over SSH onto that cloud virtual machine. That Ansible code will then execute nuclei and communicate back to Bitor its status. But we don't need to open up a port for Bitor. The way that we communicate is we actually have Bitor SSH to the virtual machine, which has a public IP address, and create a reverse SSH tunnel to send that data back. And that is the way we use as our communication channel temporarily while the scan is executed. Once the scan is complete, it actually takes that JSON file and sends it back to Bitor, and Bitor actually imports that JSON file and digests all of that data so that we can visualize it in a database, not just a JSON file. But we also take the raw results of that scan and we put it in an S3 bucket so that we can reference the raw data later if we need for whatever reason. Maybe Bitor didn't import some piece or some new feature. We have the raw data that we can go back to. That's simply how these scans work. The more scans you do, the more VMs you get, and we keep these going. As soon as the scan is done and all the data is shipped back, Bitor, it runs another Ansible playbook to, in essence, destroy the virtual machine. So the virtual machine runs its scan, gets the data, ships it back, and then destroys itself. All right, so how does Bitor work from a tech stack? So it uses Pocketbase, which is a Golang-based kind of startup web app. It takes care of some of the remedial chores of building authentication, the database itself, which in this case is SQLite. It's very actually fast, only limited by the resources you provide it. We also use Svelte as a front end, another very fast and capable JavaScript front end that you can do just about anything you want with. And then for our heavy lifting of infrastructure, we do use Ansible to actually run code on the virtual machines, and we use Terraform to deploy those virtual machines and set up the infrastructure for that to actually work. The Terraform deploy creates the virtual machine, Ansible actually runs the code, and then Terraform destroy is used to destroy that machine and clean up everything that's involved. All right, with that all in mind, let's get into a quick demo where I'm going to show you Bitor. I'm going to show you the scan and show you the results that come back. And let's go check that out. Okay, so I am now at the login for Bitor, and we're going to go ahead and log in to the dashboard here. You can see once we're in the dashboard, we have a couple completed scans that I ran tests here. And you can also see vulnerability by clients. We only have one client here. And let's go ahead and just work through kind of the basic things you need to do to run a scan with Bitor. Over in the settings here, we can go to providers. And the two things that we need to run a scan with Bitor is, one, we need an S3 bucket. We actually use that S3 bucket in two ways. We use it, one, to store the Terraform state file. And this is kind of a file that gets created when you run Terraform. We also use it to store the results of our scan. Now, let it be known, it needs to only be an S3 compatible bucket, not necessarily an Amazon S3 bucket. So what that means is that you can use other services that support S3 compatible buckets. There's a ton out there. Cloudflare has one, Backblaze has one, DigitalOcean has one, which is actually the one we're using in this particular case. And I've already configured the bucket here. I can actually change this. I'm going to change this over and say do-spaces, change the name. And then I'm going to click configure, and you can see the endpoint is actually DigitalOcean Spaces, not AWS. And the bucket is Bitor and where I want to save these files. Now, I've already inputted the API keys, but you're more than welcome to update them here through the dashboard. If you click these little test buttons, it'll actually test writing data to that bucket to make sure everything's set up right. And it's going to save the state file, which you're probably never going to have to mess with, over in /state file of the bucket. And also scans will be in /scans. Okay. The other thing we need to actually run a scan is a cloud provider. And that down here, we have DigitalOcean. And I'm just going to change this name to DigitalOcean. And if I go to configure here, it will actually use the API key, which I've already set up. And it will go look at all the regions that are available. So you can set the region, you can set what project, and then you can set your droplet size. So this is a way for you to control the cost of each one of these scans. Now, depending on how many IP addresses you're scanning, you might need to adjust the size of these droplets to get it done in a certain amount of time. You can also add tags in here. These will actually add tags to your DigitalOcean droplet, and this is an easy way to be able to track device. All right, now that we have some providers set up, let's go ahead over to clients. So this is where we would add the client that we want to scan. Right now, I just have one client, MW Group, but if I wanted to, I could actually add more clients, just enter their domain. You can also make client groups, so you could have a whole group of clients and add them in there as well. I'm going to leave it just for my one client here, just for this demo. And let's move over to Nuclei on the left-hand side. And the next thing we need to do is actually set up our profile. Now, what a profile is we're going to actually set up a Nuclei profile, and we're going to set up our scan profile. So what the Nuclei profile is, this is the Nuclei profiles that are actually pre-pulled from the Nuclei repository. If you've never used Nuclei, this is kind of a way to pre-set up what kind of scanning you want to do. The one we're going to use in this example is just this pen testing profile. If I go to edit, you can actually see the YAML data inside of here. The big things that it's setting is the type of scans it's going to do and some things it's going to exclude, primarily DOS, denial of service, any fuzzing attacks, and any OSINT. It's going to not conduct those. Now, if you had just started Bitor, you would not have these profiles, but you can add the official profiles by just clicking this button. It'll add all these things in here. Another thing you can do is an interact server. This is another concept inside of Nuclei. Nuclei has public interact servers to do certain kinds of scans. Mostly these relate to looking for certain kinds of responses from HTTP interfaces. In that case, though, you can set up your own interact servers and you can add these custom servers into Bitor so that you can control the IP address space that it actually comes from. Finally, we have this scan profile. Now, I've already set this one up. And what you can see is I have it, it's just called DO profile. Now, if I had an interact server I wanted to use with this scan profile, I could add that here. And the providers, I just have DigitalOcean. It asks you again what droplet size. It'll take the default, but if you want to make a scan profile that goes above and beyond the default, you can do that here. And then finally, we have our state bucket, which is just DO spaces, and our scan bucket, which is also DO spaces. I have checked this as the default profile, and that is all set up there. Now, the final thing before we actually run a scan is we need some targets. What do we want to scan? So targets is where we can add our list of targets. Now, you would just add a list one per line. So it could be a IP address. It could be a website domain. It could be a lot of things that Nuclei accepts. Now, you probably want to cultivate this list before, but in our case, we are just going to use one. So I'm just using scanme.nmap.org for this example, and I have attached it to the client MW group, okay? Now that we have some targets, in our case, just one target, let's go ahead and run our scan. So we're gonna go over to scan, and you can see actually 2 scans have already ran. I wanted to show you those on here because you didn't want to wait for the whole scan, kind of watching the paint dry. But I am going to show you how to build a scan. Before I do that though, you can also just manually import JSON data. So let's say that you want to run Nuclei on an internal assessment. you can actually just get the JSON file and import it, and I'll show you how we look at the findings after you've imported that data. You would just add the JSON file, give it a client name, and it'll do the import. But let's run this scan in the cloud. So I'm going to set this one up as test 3. I'm going to set InMap as our target. For scan profile, I'm going to set up the DO profile. Now, you can also, if you wanted to, go through and select the exact templates you want to use. But in this example, I'm just going to say use all templates. And for the profile, I'm going to say pen testing. Now, what this is actually going to do is it's not going to actually use all templates because the nuclei pen testing profile has already kind of cut out which ones will be used. All right. I'll say next here. I'll select my client. And you can also set up frequency. You can do scheduling. And there is a way to preserve the VM for testing if you're having issues. Let's go ahead and say create and start scanning. Now, what this is going to do is it's actually going to go in the background and it is going to start building our machine. Refresh this page. You can see now it is generating our deployment. Now, while that goes, I'm going to show you this other scan that has already completed test 2 and kind of some of the stuff that comes along with it. So the first is we actually have this button right here where we can see the log of the actual execution. So if there's any issues, we have the log data of those issues. We also have this results where we can download the zip files. We have different sizes depending on how much data you want from these zip files, but I believe both have the JSON. And after the scan completes, it actually ends up over here in findings. So if we open this up, you can see our findings. We have a way to sort through them. By default, they're already sorted by severity, but we have a lot of advanced sorting features in here where we can actually go add a bunch of different things from data from nuclei to sort by. We could sort by scan ID, by the IP address, by the protocol, other things. Additionally, we can add more than one filter. So I can add multiple filters in here, and we could keep adding filters to search through our data. Beyond that, though, we can actually look at this SSH Terrapin attack detection. You can see the address and the port, the IP that it resolved. You can see the timestamp, so when this actually scan occurred. If we, at this point, we can go to view details and see that whole finding. This is from the JSON. The extracted results, so this is what it actually was looking for. You can see references. You can see the request, the actual request it sent, and then the response that it received, right? This is all the data. Another thing for prioritization, you can actually change the severity of these findings. So you can change this to a critical from a medium, right? And if we reload the page here, you can see this has been moved over. You can also acknowledge these, false positive, remediated, so on. Finally, at the very bottom, you can do notes, and you can actually add notes to this. All right. That is a quick demo. One last thing I'll show you is over an attack surface. So another cool thing that you can do over is the attack surface enumeration. Now, some of this is still kind of work in progress, but the things that you can do is you can actually scan for domains and configure API keys. And so if we go back over to providers, we can actually add providers like Census and Chaos and Shodan to actually find domains for us in the attack surface. So we can use a top-level domain search discovery by just adding a top-level domain for the client to look for top-level domains. We could do a net block discovery, and we can also do port scanning for open ports that are available for these as well. And then we can do URL lookups to find what actual addresses, IP or domains, are running an HTTP server. Then we can take that data and actually build our target list over here, saying create from attack surface. We can include domains, subdomains, open ports, net blocks, and discovered URLs. So a quick way to build out your attack surface as well. The scan is still running, but yes, that is it. You can see the cost as it calculates directly from the value. so you have a quick way to gather cost. The last thing I'll show you is that we can obviously add more users. You can invite users. You can have groups. And so you can have set different permissions inside of here for running these scans. All right, let's head back over and finish this up. All right, we're back from the demo. And so where can I go get Bitor? So you can actually go get Bitor on GitHub. It is open source. It's free to use. It's actively maintained. I've been adding code and updates to it over the last year. You can go to bitor.dev. I've got some decent documentation up there. It's always could use some more love, but it's not too bad. So what's the future? So some of the things that I look to add in here is scan chunking. So being able to split large scans up into chunks. So if you have 1,000 hosts that need to be scanned, maybe 10 chunks per virtual machine, you'd run a lot more virtual machines, but you'd run them for a lot shorter time. Support for more cloud providers. Right now I have DigitalOcean and AWS do work, but there's some other cloud providers that could also be useful, Azure being another one. Better data insights, so the ability to kind of look at what this scan data is coming back and being able to visualize that better. Some scope enumeration, which I already have some of that starting to be building with the attack surface. Some LLM stuff, possibly for looking at this information. And yes, you can be part of the future if you want to push a pull request or add some features to this. So it's all up there. I've got a ton of GitHub issues that kind of have some of the things that I've thought of, ideas I've just kind of scratched down. I put them all up there as GitHub issues. All right, conclusions. So quick recap. Scanning at scale is hard. Now, I will say there probably are some vendor solutions you might see that can or promise to do these things, right? I went the road of building something open source that I could kind of get to really do the same stuff with. I focused on Nuclei, which I do think is amazing scanning platform because of how customizable it is and how easy it is to use. And I really think sometimes it's worth it to build it yourself. You can get a lot of value out of that, especially if you don't necessarily need all of the other bells and whistles that are inside of some of these other products. And if you're reselling it, sometimes that really can help. Collaboration is key and data is power. So I think that one of the big things I was looking for is to get a team together to do continuous pen testing. And that's really where this value add. And that having all of that data allows us to, as a team, find vulnerabilities faster. So I hope you enjoyed my talk, and maybe we will see each other around at some con. If you do see me, come say hi. Thanks, guys.